So we're going to go over the homework for 201. Let me make an adjustment. There we go. We're going to go over homework on 201. And our first question is, the astronaut is throwing his oxygen tank away to survive. And we're going to conserve momentum. And so when we look at our equation here, we're going to have that the mass of the astronaut and its initial velocity and the mass of the oxygen and its initial velocity will equal the final momentum of the astronaut and the final momentum of the oxygen. Now, initially we want to make the two items be stationary. And so our VIs will be 0. Our VIs are 0. We have the mass of the astronaut and the final velocity of the astronaut, and then we have the oxygen tank's information right here. And so we got to start solving, and we're going to multiply, get 120 there. And 63 times VF plus the 120, and we're going to have to subtract the 120 over to the other side. And then we'll end up dividing by our 63. And when you divide that out, you get a negative 1.9. Notice I used a positive velocity in the oxygen tank, and the astronaut went the other direction with the negative. If you flip-flop, you're also correct. Okay? All right. Question 2. Let me slide the notebook up. Question 2. Now we have a fisherman jumping into a boat. The boat is stationary, the fisherman is moving, and then together they move in the end. And you may, when you're going over the question, you're like, wait a minute, Mr. Wolf. I got the initial velocity of the fisherman. I've got the initial velocity of the boat. But over here at the end, I don't know how fast either of them are going. Well, then you realize that the fisherman is in the boat. And so the final velocity is the velocity that both of them have together as a group. And so this is really only one variable. It's just listed twice. And so let's do a little algebra to solve that down a little for us. And we see that, the initial stuff is, hey, stop paper. The initial stuff is the same, where the fisherman is running on his own, the boat is sitting there alone. But in the end, the fisherman and the boat end up together and moving as one. And so we can simplify that out. Plug in some numbers here. So the fisherman has a mass of 85 and a velocity of 4.3. The boat is stationary. Add together the masses of the fisherman and the boat and have a velocity there. So we're going to multiply the 85 times the 4.3 and we get 365.5. We add together the masses and get 220 times the VF. We must divide by the 220 and we get a final velocity of the person and the boat of 1.66. Now notice they are moving forward still, so you're not going to have a positive on that. Number 3, we have a couple of croquet balls, and they are identical in size. Could you do some canceling? Yes, you could do some canceling. It might muddy up your ideas though, so that's why I didn't do canceling on this. So the green ball and the blue ball, their momentum will conserve when they run into each other. So you have a G and the B for the green and the blue. And then let's plug in our numbers. To start off, the green ball has a velocity of 12 and the blue ball is stationary. After the collision, the green ball is stationary. How fast is the blue ball? So you can see how these two here, it's the exact same. We don't even have to do math right there. And then we're going to divide by half, right? Half divided by half. Our V final comes out nice and neat at 12 meters per second. So that's a very simplistic problem. So let's make it a little more difficult by moving the green ball in the final. So you'll notice here as we set it up, our initial is the same. And, a half times the 12 and a half times 0. Our final, though, is a half times the 2.4. And then half times final. So we got to calculate that out. We got a 6 plus the 0. We got 1.2 times 0.5 VF. We have to subtract the 1.2 over, leaving us 4.8. And then that equals 4.8 equals the 0.5 kilograms times V final. And then we have to divide by 0.5 kilograms. We get a final velocity of 9.6 meters per second.